here has lined up a number of activities in line with this theme. We urge you all to join the celebrations and participate in the activities planned for the week. Some of these activities include high-level policy discussions.
We are going to look at the simplification, Boolean Algebra simplification, basic laws. You can write that in your book. Boolean Algebra simplification, basic laws. Hello? Log in, we are waiting for you. We have started Jackson. So, the first laws, we are going to do a number of laws. Okay? So, the first one, I will talk about the all laws. The all laws. Or is simply addition or union states. Or this simply means that the switches are in parallel. When we say or, simply means we are adding, or the switches are in parallel, or it's a union state. Okay? So, when we have A plus A, what should be the answer? Our basic mathematics, A plus A should give us what?
2A.
Basic mathematics, A plus A should give us what?
2A.
2A. Okay? I want to be getting you. A plus A will give us what?
2A.
Yes. A plus A should give us 2A. But in Boolean algebra, there are only two numbers, 1 and 0.
0.
We don't have 2A. So, what is A plus A? In Boolean algebra. Okay? So when we say A plus A, it means that the switch is like this. Okay? Because we have A and A in parallel. In parallel. So if A and A are in parallel, what will be the result here on the bulb? Z will be simply equal to what? A. Meaning that if any of these is closed, the answer will be equal to closed. As long as and when we say A plus A, it simply means that these two switches, they are interlocked. Okay?
Yes. Yes.
When we close the top one, even the last one we have closed. So A plus A will always be equal to what? A. So when we have been able to simplify, if two identical things are adding, the result is simply one of them. Even if we had A plus A plus A plus A plus A, the answer will be simply what? A.
A.
Because all these 5 switches, they are in parallel and they are interlocked. What happens on the first one happens on the second one, on the third one, on the fourth one, and on the fifth one. So that's the first one. Okay? I'll put again. One there. What about A plus not A? what should be the answer? Phoebe, are you not making noise?
No.
Who is making noise?
She's the one, sir.
What kind of noise?
Noise doesn't mean it's opening the mouth. It can even be some other form of noise. Okay, we proceed. What about A plus not A? How does this look like in a circuit? We have A there, not A. What simply means here, it simply means that this one will always be the opposite of that one. And this one is always the opposite of that one. So, when we have such a situation, our result will always be what? 1. It will always be on here. Because when this one is closed, this one is open. When this one is open, this one is what? Closed. What it simply means here is that these two, they cannot be closed at the same time. And they cannot be open at the same time. It means at every situation, one of the two is always closed. So what does this give us? A plus not A will always be equal to 1. What about A plus 0? This is the same basic mathematics. It will always be equal to what? A. What about A plus 1? It will always be equal to what? 1. Why? Because A plus 1 simply means that we have A there and we have a 1 there. So, as long as one of these is closed, the answer will always be what? 1. So, get it this evening. You can even have A plus B plus A plus A plus B plus 1. As long as there is a 1 here, the answer will be equal to what? 1. Why? Because there are all these switches which are in parallel, and you again make them parallel to 1. This is what will conduct. So you always have a 1 there. So when we are simplifying, whenever we see plus 1, at that particular moment, the answer comes to what? 1. These are the basic laws of algebra simplification as far as the all laws are concerned. Always remember these 4. If you can't remember, you can always draw a simple circuit. We proceed. What about the AND laws? AND simply means what? The multiplication or intersection set. Or the switches are in what? Series. So when we see A multiplied by B is the same as A intersection set B which simply means that the switches are in E. It is like that. That's A plus B. I mean, that's A multiplied by B. Okay? So, what are the laws? The first one, A multiplied by A. Basic mathematics, the answer should be what? A squared. But there is no 2 in Boolean algebra. So the answer is simply A. That's all. This simply means we have this situation here. That's what it means. So whenever you close A, the first one, the second one is also closed. So the result will be equal to A, meaning that when these are closed, the answer is closed then. When they are open, the answer is open there. We proceed. Number 2, what about A multiplied by not A? A multiplied by not A. What should be the answer? Hello? What should be the answer? Yes, what's the answer? There are only 2 things. Either 1 or 0, so guess. Hello?
0.
Hello.
0.
Exactly. Why? Because we are simply saying these 2 cannot be closed at the same time. When this one is closed, this one is open. When this one is open, this one is closed. And they are in series.
The other one is closed.
As long as one of them is in series, it simply tells you that there will be an open point. And as long as there's an open point here, this will never be on. It's like you have a number of switches in series. And at one point, there's an open point. You can't see supply the other side. This is what you do when you're doing sectionalizing. You open the jumper. Oh my God. What about A multiplied by 1? The answer will be A. Because it will depend on the second status. In the previous section, what was number 4? It was A plus what?
Plus 1.
And the third one was what?
A plus 0.
Good. So A multiplied by 0, the answer will be what? 0.
0.
Because it is A in a series with an open point. Hello?
Hello.
Thank you. This marks the end of the lesson. We go to the example question. Question 5.
Yes, sir.
What was it saying? Question 5. Simplify. F is equal to ABC
A,
plus A bar BC plus A B bar C. Okay? So where do you start from?
yes.
Look at the first two. What is common here?
BC.
BC. So we can factor out BC. What remains here? A. What remains there? A bar plus A B bar C. Okay? What is A plus A bar?
A plus A bar is equal to 1.
0.
Thank you. You are thinking. That's how people become technologists. What else? What is common here?
C.
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 That's all.
Okay.
Simplify it. Understood?
Yes, sir.
You can copy. This is how people pass. Oh, can we go further than that?
We go on, we'll copy. This is
I'm saying this answer. Is it finished or we can simplify further?
it's finished.
Are you sure? Or you don't know?
We are sure.
I'm trying to confirm something because there's also what is known as the absorption law. Now, I'm trying to see if it applies here. Just a moment. No, it ends there. Okay?
Yes.
Now, what if the question said simplify and draw the circuit? Can we draw the circuit for this guy? Okay? Can I go ahead?
Yes, sir.
After I have simplified, and this is your final answer, that F is equal to C open bracket B plus A complement B bar. And then you are asked to draw the circuit. How does the circuit look like? Okay? So you start with the brackets. B plus A plus B bar simply means that B is in parallel to A and not B in series. So we have our A there in series with B bar. Are we together? Is that okay? This is this part. Okay? A in series with B bar. These are in parallel to what? To B.
That.
Are we together? And the
Yes.
whole of this is in series to what? C. Your F. That is your circuit. And that is how people graduate. And the Minister of Science and Technology will be very happy. We are graduating in 18 technologies and the people will be clapping.
Alright.
This is the switching circuit. What about the logic circuit? This is the switching circuit. Because you have put switches there. What about a logic circuit? You have to put logic gates. So here there is an AND gate here. This is an AND gate. Here. This. Because they are in series is an AND gate. So we start. The AND gate is straight like this. That's the AND gate. What are the inputs A and B bar? That is B. When you invert B, you get B bar. Okay? This one goes into in parallel with what? B. That is B. You are simply saying we have our A there, we have our B here. Before the B goes here, we can tap into there in series. Okay? So what you have here is A multiplied by B bar, which is this one. What you have here is what? B. They are in parallel. Okay? This is an AND gate, which is the series. You don't even need to write there. This is an OR gate, which means the parallel. From here, these are in a series. Everything here goes in series to what? To C. And out here, we have our output what? F. So this is a switching circuit. This is a logic circuit. Switching circuit, you use the switches. Logic circuits, you use the logic gates. And these things, you are going to find them in digital electronics. This is how we design digital gates. So here we have A dot B because they are in series. Here it will be A dot B plus B. Okay? Because they are what? parallel. And what comes here is a C. The same C here has just come. So what comes out here is this C in series with this guy here. And that is how you will be counted among the educated in this country. I like the silence. Yambeka,
Yes, sir.
we proceed. Let me do the last one on question 5, where the question just says, draw the logic function. Draw the logic function. Draw the logic function of f is equal to a plus b in brackets bar multiplied by c. Can we start with a logic circuit? I mean with a switching circuit. Now I'll just go straight into a logic. So a and b are in parallel, right? So we have a there, b there. Are we together? Yes. But this, what comes out of a and b, there is a bar. Are we together? So yes. You just put a zero here. You put this. It means that this OR gate has become a NOR gate. You have transformed the OR gate into a NOR gate. And this should be in series with what? C.
C.
If that is all, and you get your 8 marks, and you be counted among the educated. Kwasiya, no magic. My director, Victor Bimapani, will say, there's no witchcraft. My MD, Engineer Victor Benjamin Mapani, he will say there's no witchcraft. That we are where we are. Hello?
Hello.
Yes, sir.
I'm finished. Can we do another one? Can we proceed? We do the other question?
Yes.
Yes.
Where, let me look for another question where we need to do the truth table. Okay. Or
Okay, sir.
Let's just modify the question. This very question, and they said draw a truth table. Okay. From this one, draw the logic circuit and draw the what? The truth table. How do you draw the truth table? Please, there is nothing called the first table. There is only truth table. Wamela Phoebe. There's nothing called the first table. There's only the truth table, okay?
Okay.
So how do we draw a truth table? First, in drawing the truth table, first thing, number of inputs. Okay? How many inputs are here? This was F is equal to A plus B, C. How many inputs are here?
3.
There are 3. Just look at the different letters. There are 3 different letters. So there are 3 inputs, okay? So the number of inputs will give you the number of rows on your truth table. How do you get the number of rows? Is 2 to the power n, where n is the number of what? Inputs. So in this case, 2 to the power 3, 8. Okay?
Yes.
Yes.
So our table is going to have 80 inputs, meaning there are 80 possibilities. Okay?
Yes, sir.
So we draw the 80 possibilities. So we start. We are going to have A, B, C, and the F, where F is our output. Like that. These are columns. The rows, the horizontal ones, must be 8 lines. So I'm going to have 1, 2, 3, 4, 5, 6, 7, and 8.
8.
Kwa maana. So, how do you put the numbers here? What is 8 divided by 2?
4.
So, you're going to have 4 zeros. 1, 2, 3, 4. Then 1, 1, 1, 1. Okay?
Okay.
Yes.
Yes. Then you come to here. How many zeros are here?
Yeah. 4.
Yeah, 4.
4 divided by 2.
2.
So 0, 0, 1, 1. 0, 0, 1, 1. We come here. How many zeros are here?
2.
Yeah.
2 divided by 2.
By
1.
1.
1.
Please, my son is listening in the sitting room. So
It's answered.
2 divided by 2, 1. So 0, 1, 0, 1, 0, 1, 0, 1. Then we have captured all the possibilities. This part will always, as long as there are 3, this part will always be filled in like this. Nothing changes. Okay?
Okay.
So let's fill in the last column. I'm remaining with a few minutes. The last column, those are the answers now. Okay?
Yes.
So here, gentlemen, the issue is this side. Since this is a series, the only time we are going to have the 1 here is when there is a 1 here and when there is a 1 there. Are we together?
Yes.
So wherever C is 0, F will be what? 0. Do you agree? Wherever
Yes.
C is 0, F will be what? 0.
0.
Because they are in series.
Yeah, in the series.
So we start with C because the C goes in straight here. So wherever C is 0, F will be what? 0. So there will be 0 there, there will be 0 there, there will be 0 there, there will be 0 there.
Okay.
Where C is a 1, There must also be a 1 from here to give us what? 0. So, let's start. When A is, we are here now. Here we are already done. Let's come here. A is 0. When it is 0 here, it will be 0 there. Are we together? We have A0, B0. Have you seen? 0, 0. What will be here? What comes out of an OR gate? If it is 0, 0 here, what will come out here is what? It says 0.
Yes.
But remember, this is not an OR gate. This is a NOR gate. Meaning, there will be 0 here. Listen, this gate here is the same as this. It's like you have a 0 here, 0 here. Here you are going to have what? A 0. When you invert a 0, you get a what? A 1. You have seen it?
Okay.
So 0, 0 goes in. But because this is a NOR gate, what comes out is a 1. So there is a 1 here. And since there is a 1 here and the C is also a 1, we are going to have a 1 there.
Okay. Yes.
This is logic gate. We use the brains here. Thank you. Next, we come here. 0, 1. If there's a 0 here and there's a 1 here, what comes out? This is an OR gate. 0 and 1, what comes out is a 1. The 1 is converted, it becomes a 0. So if there's a 0 here, it will be 0 there. Equal when we come here, okay? We have a 1 on a 0 on a B. There will be 1 here, converted, 0. It will be 0 there. We have a 1 and a 1 there. A 1 and a 1 will give us a 1. Convert a 1, it will give us a 0, 0. That is the truth table. Okay. You are going to watch the video. You watch the video, go through it, choose the video. Otherwise, thank you so much. May the Lord literally bless you. Thank you.
Amen. Thank you.
Good night.
Thank you.
Good night.